Magnetar. It is the most magnetic object in the known universe. Not slightly, not impressively, violently. A magnetar's magnetic field reaches 10 to the power of 15 Gauss. Earth's magnetic field is half a Gauss. If a magnetar sat where the moon is right now, it would pull the iron from your blood before you could blink. Here's the part that should bother you. We can detect them from halfway across the galaxy. One magnetar, SGR 180620, released more energy in zero point 0.2 seconds than our sun emits in 250,000 years. In a fifth of a second. Gone. They are born from dying stars. Massive collapse. Insane spin. Some rotate 700 times per second. The crust is so rigid it barely moves, but when it does crack, it releases a starquake. That starquake hits Earth as gamma radiation powerful enough to ionize our upper atmosphere from 50,000 light years away. Let that sink in. A crack on an object smaller than a city, felt across half the galaxy. We know of fewer than 30 magnetars. The universe may be full of them. Quiet. Waiting. But a magnetar is at least something we can see. What comes next, we almost cannot. Dark matter makes up 27% of the universe. We have never seen it. We have never touched it. We have never detected a single particle of it directly. Here's what we know. Galaxies spin wrong. The outer edges move at the same speed as the inner edges. That should not happen. By all known physics, the outer stars should fly off into space. They don't. Something holds them. We call that something dark matter. It passes through you right now. Billions of particles per second. Through the Earth. Through the walls. Through every instrument we have ever built. No reaction. No signal. Nothing. We have mapped it. Indirectly. Using gravitational lensing, the way massive objects bend light. Dark matter bends light too. We can see its shape. We just cannot see it. It is not dark like a shadow. It is dark like a gap where physics stops making sense. Here's the twist. Some models suggest dark matter may not be a particle at all. It may be a field, or a fluid, or something for which we do not have a category yet. The universe is mostly made of something we cannot identify. That is not a mystery on the edge of science. That is the center of it. Something even stranger happens when matter falls toward the densest possible point. Quasar. This is the brightest object in the universe. Not a star. Not a galaxy. The core of a galaxy actively devouring. A quasar outshines its entire host galaxy by a factor of 100. Some by 1,000. The most luminous quasar ever found, JO 5294351, releases energy equivalent to 500 trillion suns. Every second. Here's how. A supermassive black hole at the center of a young galaxy pulls in surrounding matter. That matter forms an accretion disk, a flat spinning ring of superheated gas. The friction makes it glow. Not just glow, blaze. Shoot plasma jets millions of light years long at nearly the speed of light. We can see quasars from 13 billion light years away. We are looking back to when the universe was less than a billion years old. These are not current events. These are fossils, light that left before Earth existed. Here's the unsettling part. Most large galaxies, including ours, have a supermassive black hole at their center. Ours is called Sagittarius A star. It is currently quiet, dormant, not devouring. But it was a quasar once. The Milky Way blazed. Everything in it was bathed in that light. Quasars are what galaxies look like when they are hungry. Our galaxy is full. For now, the edges of the universe hold quasars. But even further in the dark, something stranger pulses. Fast radio bursts. They last milliseconds. They release more energy than the sun produces in 3 days. And for years, nobody knew where they came from. A fast radio burst, FRB, is a burst of radio waves. Incredibly powerful. Incredibly brief. The first was discovered in 2007, buried in old telescope data. It had happened in 2001. Nobody noticed for 6 years. Here's the problem. They come from random directions, random distances, billions of light years away, and then they are gone. No repeated signal, no pattern, no warning, except some do repeat. FRB 121 Leno 2 is fired hundreds of times. No explanation for why some repeat and others don't. The sources appear to be magnetars in distant galaxies. Possibly. We are not certain. Here's the number. In a single day, roughly 10,000 fast radio bursts reach Earth. 10,000. Most go undetected. We only catch a fraction. The sky is full of screaming radio pulses from across the universe, and we are only just learning to listen. What generates that kind of energy in milliseconds? Colliding neutron stars? Magnetar flares? Something unknown. The honest answer is we don't know. And that answer is rare in modern astronomy. There are objects in space so extreme they broke our models entirely. One of them you have heard of, but not like this. Neutron star. You think you know this one? You don't. A neutron star forms when a star between 8 and 20 solar masses collapses. The outer layers explode. The core survives. It compresses from a star 10 times the size of the sun to a sphere roughly 20 kilometers across in under a second. Here's the density. A teaspoon of neutron star material weighs approximately 1 billion tons. Not the whole star. A teaspoon. The gravity is so strong that the escape velocity from the surface is half the speed of light. Sound cannot exist on a neutron star. It would propagate faster than the speed of sound allows. The physics breaks. But here is the part that genuinely unsettles astronomers. We don't know what the inside looks like. The center of a neutron star may be so dense that protons and neutrons dissolve. What remains may be a state of matter called quark-gluon plasma, the same state that existed microseconds after the Big Bang. Or it may be something else entirely. Something with no name yet. We cannot recreate those conditions. Not even close. We are studying the interior of neutron stars by watching how they wobble from thousands of light years away. And sometimes two of them find each other. Neutron star collision. In 2017, two neutron stars merged 130 million light years away. We felt it. LIGO detected the gravitational waves, ripples in spacetime itself, 1.7 seconds before light from the explosion reached us. That 1 7-second gap confirmed something Einstein predicted a century ago. Gravitational waves travel at the speed of light. The collision, called a kilonova, was brighter than a billion suns for a fraction of a second. Then it faded. Here's what it left behind. Gold. All the gold in your jewelry, every gold bar in every vault, all the gold on Earth, it came from collisions like this one. Neutron star mergers are the factories of heavy elements. They produce more gold in one event than the sun will produce in its entire lifetime. The ring on your finger is stardust from a catastrophe 130 million years ago. Let that sit. These collisions are rare but calculable. And what they sometimes produce is more mysterious than the stars that died to make them. Black hole, the interior. You know, black holes exist. What you do not know is what happens inside. At the center of a black hole is a singularity, a point of infinite density, infinite curvature. All the math collapses. Our equations produce infinities, and infinities mean the model has failed. Nobody knows what is actually there. A singularity may not be physical. It may be a signal that our physics is incomplete. General relativity breaks at the singularity. Quantum mechanics breaks at the event horizon. Both our best theories of reality fail inside a black hole simultaneously. Here's what that means. There is a region of the universe, potentially many regions, where we have no working model of what exists. We can point to it. We can measure its effects. We cannot describe its interior. The information paradox makes it worse. Quantum mechanics says information cannot be destroyed. A black hole appears to destroy everything that falls in. Stephen Hawking proposed that black holes slowly evaporate via Hawking radiation. But where does the information go? 40 years later, this is still unsolved. Some physicists propose that the interior of a black hole is actually the exterior of another universe, that black holes are birth events, that somewhere a new cosmos expanded from the point where a star collapsed here. You cannot test this. You cannot go in and come back. The event horizon is a one-way door. What we know is this. The universe contains objects where our best science fails completely. And we have found them. We are watching them. We just cannot fully understand them. Not yet. But here's the final object. It isn't dramatic. It doesn't explode. It doesn't scream radio waves or bend galaxies. It just sits there doing the strangest thing in physics. The cosmic void. Between galaxy filaments, there are voids, regions of space nearly empty of matter. The Boots void is 330 million light years across. If the Milky Way were inside it, we would not have known other galaxies existed until the 1980s. Here's the strangeness. Voids are not random. They form a structure. The universe at the largest scale looks like a cosmic web, filaments of galaxy clusters connected by vast dark emptiness. It is the largest structure we know of. It has a name, the cosmic web. Nobody made it. Gravity and dark matter pulled it into shape over 13 billion years. The voids are growing. The universe is expanding. Dark energy, another thing we cannot directly detect, is accelerating that expansion. The voids between galaxy clusters are getting larger. Eventually, in the far future, every galaxy cluster will be so far from every other that light from the nearest neighbor will never reach us. The universe is not just mysterious now, it is becoming more mysterious. Actively, measurably. We are living in the most connected, most observable period the universe will ever have. In a trillion years, any civilization that exists will look out into total darkness. They will not know other galaxies exist. They will not know about the cosmic web. They will think the universe is just their galaxy, alone. They will be wrong, and they will have no way to find out. You know, you are here now in the brief window where the evidence is still visible. Use it.